Hello Earth Science students, this video is showing you some examples of how to use Kepler's third law to solve for either orbital period or distance to the sun, and also it has directions for how to use our classroom calculators to carry out these functions. So we're just going to work through the first couple of problems as examples here. Start with the directions. Using Kepler's third law to solve the following problems. If needed, round answers to 2 decimal places. For answers in kilometers, make sure to use scientific notation. So remember, scientific notation is when you write big numbers in a shorthand form using this times 10 to the sum power to account for all of these extra little zeros that we have. Okay, let's do number 1 here. So number 1, Mercury orbits the sun at a distance of 0.4 AU. What is Mercury's orbital period in Earth years? Since we got to make sure that we pay attention to what our answer is going to be, it's going to be in years. It gives us the distance. So if we have our formula t squared equals d cubed, we want to find the time, we have the distance. So we have t squared equals, our distance is 0.4 AU, so 0.4 cubed. On our classroom calculators, the way that you cube a number, 0.4, and then this button here that has the x cubed, you just hit that button and then equals, and you get that number cubed. So we have 0.064. T squared equals 0.064. Since we have t squared, to get the squared away from the t, we have to take the square root of this number. And so to do that on our classroom calculator, we just hit this key, this square root key right here, square root, and then this answer key, and that's going to put our answer from the previous equation we did right into the square root here. And so we get this number, 0.25298. So t equals, and remember in the directions it said to round to 2 decimal places, so t equals 0.25. And since our units, we want our Earth years, this is years. Okay, let's do number 2 together. Venus has an orbital period of 0.62 Earth years. What is Venus's distance from the sun in AU? So we're gonna have AU as our units in our answer. It gives us the orbital period time, and so we wanna find distance this time. So now we have t squared equals d cubed. We have the time, 0.62 squared equals d cubed. We gotta clear this on our calculator. So now to do 0.62 squared, our squared button on the calculator is right next to the square root button. So it's this x squared one here. So we hit the squared and equals 0.3844. 0.3844 equals d cubed. So up here we had to take the square root of this number to get the square away from the t. And now this time we're going to have to take the cubed root of this number to get the cube away from the d. So to do that, on our calculator, you have to press this shift button, shift, and then the x cubed button, this little orange deal above it, it's got the x cubed, so you just hit shift and then the x cubed and you get the cube root. And then again, you hit your answer key and then equals, so 0.7271. And since we are rounding to 2 decimal places, we just put 0. This will round to 0.73. 0.73, and our units are in AU. Okay, so those are like the reverse, finding the orbital period in number 1, finding the orbital distance in number 2. We're going to do number 3 as well, because this time it's going to want your answers in kilometers, so it's going to bring that scientific notation piece in. So now we have Mars has an orbital period of 1.9 Earth years. What is Mars's distance from the sun in kilometers? Okay, so we'll start and we'll solve for, since we have t squared equals d cubed, we have the orbital period, which is t. We'll just solve for d, and then we'll convert d into kilometers at the end. So t squared, or we have t, excuse me, we have 1.9 squared, because that's the orbital period, equals d cubed. So on our calculator, again, we take 1.9 squared equals 3.61. 3.61 equals d cubed. We have to take the cube root again. So shift cube root, answer equals 1.53. 1.53 equals d. So now we have this. This is in AU because the d is in this equation is always like defaults to astronomical units, AU, but we can easily convert that into kilometers because 1 AU is equal to 150 million kilometers, or 1.5 times 10 to the 8 kilometers. And so all we have to do is take our AU and multiply it by this number. So we just do 1.53 times this 1.5 times 10 to the 8th, 1.5 times 10 to the 8th equals, and now I'll show you how to do the scientific notation on our classroom calculators. So we've got 1.53 times 1.5, and now this is how you enter scientific notation on these calculators. You hit shift, and then this button that says log on the actual button, this 10 to the x, so shift, and then this button, and it gives you the little 10, and so then you just put in whatever the exponent was that's in your scientific notation, and in this case it's an 8, so we put an 8, so 1.53 times 1.5 times 10 to the 8 equals, and it gives us this big long number. And so remember, for scientific notation, what you do is plop the decimal point in between the first two numbers and then hop and count how many times 10 to the whatevers you have. So in this case, since we're rounding to two decimal places, we're going to put 2.30. That 5 rounds up the 9 and that rounds up the 2. So we're going to put 2.30 times 10 to the, we put our decimal place here and then we hop it over to the end and count how many places. So we start here, 1, 2, 3, 4, 5, 6, 7, 8. So 2.30 times 10 to the 8th kilometers is our answer for question number 3.